In this lesson, I'll show you how to obtain the empirical formula for mass percent. This is part 2 in the series. The question reads, a laboratory analysis of aspirin determined the following mass percent composition: 60% carbon, 4.48% hydrogen, and 35.52% oxygen. Now, what I would like you to do is pretend that we had 100 grams of aspirin. If we had 100 grams of aspirin, we would have 60 grams of carbon, we would have 4.48 grams of hydrogen, and 35.52 grams of oxygen. What I would like to do is multiply each of these masses by the molar mass. So I'll take 60 grams and multiply it by 1 mole over 12.01 grams. Let me show you what I mean. So I'll take 60.00, which has 4 significant figures, and I'll write that down over here. And I'll multiply this by 1 mole over 12.01 grams. What this will do by multiplying 60 with 1 over 12.01 is I'll end up with the number of moles. And then I can use that as a basis to building up the empirical formula, which is what they're asking for. Next, what I'll do is multiply 4.48 grams times the molar mass of hydrogen, which is 1 mole over 1.008 grams, and this has 3 significant figures. And lastly, 35.52 grams times the molar mass of oxygen, which is 1 mole over 16.00 grams. Notice that the gram units will always cancel out in each of these 3 computations. With that done, let's find out what these numbers are, and I'll use my calculator. I'll start with 60 divided by 12.01. 60 divided by 12.01, and this gives me 4.996. I'll stop at 4 significant figures. 4.99, and this 5 goes up to 6. And this is in moles. Now let's do the hydrogen using our calculator. 4.48 divided by 1.008, and that gives me 4.44. 4.44. I'll stop at 3 significant figures. And finally, 35.52 divided by 16, and this gives me 2.22. Now, to build my empirical formula, I'll write down the atoms within this compound. I have C, H, and O. And I'll write down 4.996, and since 4.99 is so close to 5, I'll just write down 5 right here as the subscript for carbon. 4.44 will be placed right here, 4.44, and 2.22 will be placed right here. Notice that these numbers are decimals, and normally when you look at a chemical compound, its formula, the subscripts are integers, they're whole numbers. So to do that, what I will do is take the smallest of these subscripts, which is 2.22, and divide each of the subscripts by that. Look what happens. If I divide this by 2.22, it becomes 1. That means we have 1 oxygen atom so far. Let's divide 4.44 by 2.22. In fact, if you do that, you should end up with 2. And lastly, we have 5 divided by 2.22, and that gives me roughly 2.25. 2.25. I'll continue my work over here. So I have C 2.25, H 2, and O1. 2.25 is not a whole number. We need to make this into a whole number. 2.25 is actually the same thing as 2 1/4. 2 1/4 is the same thing as 9 over 4. And if you don't believe me, you can place these in your calculator. You'll find out that they equal to 2.25. Now, because 9 is over 4, I need to multiply each of these atoms, each of their moles, by 4. So if I multiply this number by 4, I end up with the 4's canceling out. I end up with only 9. C subscript 9. I have to multiply the 2 by the 4. That gives me H8. and I have to multiply this 1 by 4, and that gives me O4. C9H8O4 represents the empirical formula for the percentages given in this analysis. If you would like to see the solution to question number 2, make sure to watch part 3 in this lesson.